This video is on preparing data missing value options. In this 11th video, we consider how to cope with missing values in the data. We illustrate with data from 4 stations in Niger. The rainfall and temperature data are to be summarized. Start with an inventory plot. This shows there are relatively few missing values except for the mid-1960s. There are more missing values in the rainfall than the temperatures. The display daily dialog can also be used. These displays show that the data from Niamey starts earlier than the other stations. There is quite a lot missing in these early years. Also, the early Tmax data looks as though it isn't homogeneous. That gives an initial way of coping with missing data, namely, omit those years completely. We use the data from 1945 for all the stations. Right-click, choose Filter, and define a new filter with the year greater than 1944. As this is going to be used from now on, choose the option to produce a subset and call it Data 45. This gives a new data frame. Return to the Display Daily Data dialog and move to the new data frame. The variables are included again. These are now the data for analysis. You become a data detective to undertake the analysis. So, you wonder about oddities. An odd feature of this data is that there are more missing values in the rainfall in the mid-60s compared to the temperature data. It is usually the other way around. We see later that it is right to pay attention to this point. The inventory plot showed this feature clearly. The main climatic summary dialog is as follows. Rainfall is considered first. Start with the summary at the annual level, select the rainfall. Also, specify which summaries to produce. Untick the N total, which you know is about 365 days each year. Leave N non-missing and the sum. That's it, so press OK. The results are in a new data frame. There are 144 rows, with each being the annual total from the 36 years for each of the 4 stations. For one of these stations, Birni Nkoni, the annual summary is set to missing in 13 of these years. For some analysis, this may be okay because there remain 23 years where the annual total is given. Looking more closely, there were very few observations in some years. For example, 1965 was just 48. In other years, like 1967, the result was missing even though just one day was not recorded. This is one way of dealing with missing values. This way is safe. Another option for the missing values is shown here. With this option, the missing rows are omitted, and the summary is taken of those days that remain. Now, there is a surprise. With just 48 non-missing values in 1965, we expected the totals to be low. What is happening here? We digress and look more closely at the daily data before returning to the main topic of missing values. In an earlier video, we claimed that you omit the quality control step at your peril. You always get dragged back. We really should have applied this to ourselves. We drag ourselves back. Start by looking more closely for Birni and Coney in 1965. The missing values in the rainfall are clear. Also, there are no missing values on the same days in the temperature. Do you notice anything odd about the rainfall? Well, did you notice? There are no zero values. Maybe all the dry days have been coded as missing instead? There is also an odd value of 99.9. There is nothing wrong with 99.9, except it is an odd value to just sit there. Might it signify a real missing day instead? Scrolling sideways, we see there were 11.3 hours of sunshine on that day too. So that rainfall, if it is true, was only at night time. It is time to do more checks on the rainfall data. The one for consecutive rain days was done as shown. This gives a new data frame with 5 occasions to examine. The first was near May in August 1950 when there were 13 consecutive rain days. Then, August 1957, similarly. Then, in June 1966, there were 30 consecutive rain days. Similarly, Zinda in May 1965 and February 1966. Each had 28 consecutive rain days. As a data detective, there is clearly something wrong here. The quality control is usually done by an experienced meteorologist, but you don't need much experience to know that February in Niger is the middle of the dry season. So those consecutive rainy days in February must be an error. August is the rainiest month in the year, and this first spell of consecutive rain days looks plausible. In contrast, here is June 1966. These don't look like rainfall data. They are more like sunshine hours. And the consecutive rain days start exactly on the first of the month and continue for the whole month and then stop. So what's next? Ideally, the corrections will be made and an improved set of data provided for analysis. These data were prepared by the French Met Service as part of a large data rescue project, and the original data are in the archive in France. We have contacted them. Temporarily, the 3 months in error could be changed to missing values. They are anyway in the years where many dry days have been declared as missing. We return to the main topic, namely, what options do we have for the analysis when there are missing data? Two extremes have been shown so far. The first is for the summary to be missing if any data are missing within that period. That's safe, but there are then fewer years of data for the subsequent work. Now, repeat with this safe option for the temperatures. The second alternative is to summarize the non-missing values. This is not safe, but gives more years of data for the subsequent analysis. So far, we have used the standard alternatives offered with almost all R functions. Either the result is missing if anything is missing, or if anything is missing, then carry on with what's left. R-Instat adds further options. With the missing checkbox ticked, use the Missing Options button. As an example, use the first option and limit the number of missing values to 27. That's less than a month, so any missing month will give the result as missing. In the results, when there are 319 values, the result is still missing, but the summary is given in the following years when just a few days were missing. Finally, use the same idea with a monthly analysis. Change to annual plus within and include the months. Choose the missing options again and change the value. We chose 5 here. So the result is set to missing whenever there are more than 5 days missing in any month. Confirm that 1728 rows of data is expected. That's 144 from the 36 years, and 4 stations with now 12 observations per year. The results show that in 1945, January and February are missing because more than 5 values are missing. March and April are present because they each have just 1 day missing each.